Good morning, everybody. Thanks for coming to the session, delivering on the promise of generative AI with Supercomputing-As-A-Service. My name is Thomas Odenwald. I work for Hewlett Packard Enterprise. My background is I worked for a long time for a company called SAP in business applications, and then worked for several startups in the AI space. Had my own startup before, unfortunately, COVID. Came across to that, and while working at my own startup, I also worked for space company, building gas stations in space. So some of you might know what they say about people who dealt with rocket fuel in their past. I want to introduce you real quick to Hewlett Packard Enterprise, because some of you already asked me if I can help fix your printer and your laptop. That's the sister company. So Hewlett Packard Enterprise split 7 years ago into Hewlett Packard split 7 years ago into Hewlett Packard Enterprise and Hewlett Packard Inc. Hewlett Packard Inc., our sister company, that's where you buy our printers and your laptops. Hewlett Packard Enterprise, my company, is responsible known for the best hardware in the server market. We own actually 40% of the HPC, the high performance compute market. We build the biggest supercomputers in the world. We recently rolled out Frontier together with Oak Ridge Laboratory, which is the fastest supercomputer ever being built, 1.1 exaflops, faster than the other 7 fastest supercomputers combined. If you want to have more metrics on that, we built 7 of the 10 greenest supercomputers as well as 3 of the 10 fastest supercomputers in the world. That's what we are known for. But what I want to talk about today is what is lesser known, namely the fact that Hewlett Packard Enterprise is recognized by leading analysts like CRN, IDC, Forrester as a market leader in the AI space as well. So before I go a little bit deeper into that, this is the lens we are looking at the AI market today, and I'm sure you heard some of these stories in all the sessions that happened yesterday and today already. 98% of the customers that we talk to already have an existing AI strategy. You heard in the keynote yesterday, only 1% can recognize a measurable ROI today. If you go deeper into that, what we see is that a comprehensive data strategy is the foundation for your AI initiative, but 80% of the time today is spent on gathering, analyzing, cleansing, reorganizing data, and 63% of people we talk to, data engineers, data scientists, are very skeptical if they indeed work with the right data sets all the time. If you move to the right and look at AI development and deployment challenges, scaling into production is a huge problem today. Only 14% have fully realized their AI strategy. 89% need help to scale their AI initiatives into production. And that's where our focus is. A little bit about the history, where we are coming from, where we are heading to, and that has to do with using this knowledge from these supercomputers that we are building and bring that to the commercial industry. So from the hyperscale area, and hyperscale refers to the mix of hardware and facilities to scale up distributed computer environments across thousands of servers. So we are now moving from the hyperscale area to the exascale area. And on that way, we made very, very targeted acquisitions to bring up the AI portfolio that we have today available. We recently acquired a company called OpsRamp in the AI-driven operational management space. We acquired Pachyderm very recently, also in January this year, for machine learning data management. And before that, you see also Determined AI, which is now called internally Machine Learning Development Environment. And I'll go a little bit deeper into what these tools and these frameworks do for us and how you can also leverage them. A typical enterprise-grade AI stack, the way we look at it, looks like this. So you need the high-performance infrastructure underneath. I'm starting on the lower level here. You have the optimized infrastructure that has your compute, that has your storage capabilities, that has high-performance fabric, and that has a range of AI accelerators. I mean, I just saw the NVIDIA stock price this morning. It's up 200% year to date. That's why GPUs are so essential for everything we do in the AI space. And from our perspective, we are using different kinds of accelerators, but they are an absolutely critical part of the hardware infrastructure underneath. On top of that, you have the software stack. And the software stack starts with the data management piece. You need to have capabilities for data lineage. You need to be able to version your data sets. You need to be able to create data pipelines that go then into the development and training cycle. And in the training cycle and the development cycle of these models, you need to be able to scale up. You need to be able to train large-scale machine learning models faster while hiding the complexity of the infrastructure underneath. That includes experiment tracking. That includes sharing your training run with others. That includes optimizing your cluster, your GPU clusters across GPUs that are idling at the time when you need them. So all this is baked into most up-to-date model development and training frameworks and services. And then, of course, you deploy these models into inference, and deploying and managing these models and running inference on heterogeneous infrastructures can happen on the data center, can happen on the far edge, or can happen all the way out there on the edge. And then, of course, you have the applications on top. We work with very selected ISVs across different industries that bring additional value so that we can combine these platform capabilities into a comprehensive end-to-end solution for our customers. All this today needs to be based on what you know as cloud experience. That includes self-service, that includes that you can pay by use, pay by the drink. You scale it up and down through elasticity. You have managed services around that, and so on and so forth. So that cloud, that infrastructure layer needs to take care of your governance, it takes care of your billing, takes care of your security, and so on and so forth. So that's how we look at an ideal software stack in the AI world for your AI applications. This is an example, comes back to the template before, of one of the biggest lifecycle companies that recently installed that stack as their MLOps solution. And the reason why they chose us is for three reasons, basically. One is the capabilities itself that we bring to the table, in this case through our data processing and pipelining solutions. This is HPE machine learning data management. Determined AI, now called machine learning development environment, that allows distributed training and hyperparameter optimization. In terms of model deployment and monitoring, we refer to open source. We refer to the leading open source tools that we offer, in this case, to our customer as a managed service. And they really like that. One of the reasons why they choose us is, first of all, you can get the software, the hardware, and the services from the same vendor. Second of all, they like that managed services piece because they don't have to deal with the upgrades, the patches, the bug fixing of the open source solutions. But they also really appreciated that we, from the very beginning, were very clear what we can do and what we cannot do with our MLOps capabilities. All that sits on top of our distributed data plane, the file and object store called HPE Ezmeral, and underneath you have the scalable AI infrastructure, which we call HPE GreenLake. And that, again, as I said, takes care of the governance, the billing, the security, and so on and so forth. Through this solution implementation, we increased hyperparameter search optimization 14x. We reduced the costs that they had before with their homegrown solution by 70%. And we reduced training of their models from 3 days to 3 hours. So that's talking about the 1% ROI. Maybe we are part of that 1% because we could bring up a measurable ROI in this scenario. Switching to the title of this session, Language Models as the Foundation for Generative AI. According to Boston Consulting Group and McKinsey, they have the potential to disrupt every industry. They have the potential now to promise a competitive advantage. And what Boston calls creative destruction, they change the anatomy of our work. They augment the capabilities of the knowledge workers and could automate 60 to 70% of today's activities. Oh, I wanted to also mention everybody, when looking at this slide, thinks of ChatGPT, because thanks to ChatGPT, it created, of course, this huge hype. Does anybody know what it takes to train ChatGPT, one training run, in terms of costs? Anybody has a guess? It's $3 million. Costs $3 million to train ChatGPT once. That's why when you do certain prompts, it tells you the last time it was trained was 2021. It costs $700,000 per day to run ChatGPT in inference. The power consumption of ChatGPT, according to a study from Professor Patterson, is 1.2 million megawatts. That's the equivalent of 120 homes and their energy consumption throughout the entire year. And the reason I'm mentioning that is because sustainability and energy efficiency is a very important KPI for us in whatever we do. Large language models require supercomputing capabilities. Hence, I made the introduction on how we leverage our knowledge building these kind of supercomputers and bring it to you and bring it to the commercial industry to develop, to train, to tune, and to deploy these very compute-intensive generative AI applications. The computing requirements for large-scale AI models doubled every 10.7 months from 2016 to 2022. And there's no end in sight that will change anytime soon. So we believe large language model applications need to run on the most advanced supercomputing software and architecture possible. That includes, again, they run on unmatched scalability and reliability. That's a prerequisite. So these hardware infrastructure and the accelerators and the compute and the storage underneath are absolutely essential to be done right. You need built-in partnerships in order to make LLM, large language model applications, run. That could be pre-trained or pre-configured large language models. That could be data. That could be capabilities like different languages, multimodal, explainability, which is coming up more and more now, security, privacy, different deployment options, and so on and so forth. You want to host it in an AI-native data center. I'll come in a second to what I mean by that. Ideally powered by 100% renewable energy, because you just heard what it takes ChatGPT in order to run on a daily basis. And you want to make it accessible on demand and backed by managed services. That's, in our view, the prerequisite in order to make large language models pervasive across every industry. So when we look at the options, and this is important because we made a significant announcement just very recently in order to bring that desired state in the middle to our customers and prospects. The benefits and the pros of using a traditional data center and 100% liquid cooled supercomputers is it's extremely efficient. You can run it 24/7, you can scale up jobs. It has an unbeatable price performance. No egress fees. Egress fees, as you know, is a topic that comes up more and more. The downside, of course, if you read the other bullet points, is it requires a large upfront CapEx investment, and it's not instantly available. It takes time in order to build a data center, and you need the skills, and you need to build up the skills with your staff for running a data center infrastructure. On the right-hand side, the alternative, namely to go with traditional public cloud from major cloud service providers, and I just want to refer to a study from Andreessen Horowitz that came out where he said, "You are crazy," and I'm quoting, "You're crazy if you do not start your AI journey in the cloud." And then it says, comma, "You're crazy if you stay in the cloud over time in your AI journey." So I'm happy to give you the reference on that article that came out recently, but it basically refers to what you see on the right-hand side. So you have HPC, high performance compute, and AI instances available with GPUs, with CPUs. You have fast interconnect, you have storage, but it can get very expensive very, very fast. Data egress fees are unpredictable. Everybody who felt the pain knows that and recognizes that. But on the other hand, easy to access. It's instantly available. You can get instantly started with a proof of concept. It shields you from the skills that you need to build up to run a data center. You don't need to worry about that. You have a cloud-based consumption model. You pay by the drink. and you have a very short time frame, a short time lag from decision to production. So the desired state that we identified is in the middle on the best of both worlds, right? You take the best from a traditional data center approach, you take the best of what the public cloud has to offer, and because of that, HPE recently made an announcement where we now offer Supercomputing-As-A-Service. Hence the title of this session, Supercomputing-As-A-Service, where HPE now is providing a cloud supercomputing infrastructure as a service layer with a platform as a service capability baked into that. We announced that, I think 3 or 4 weeks ago. And again, this is excerpt from an interview with our CEO, Antonio Neri. It is called HPE GreenLake for large language models. And this allows you to instantly get access to the power that you need, the compute power, the compute platform that you need to train, to tune, to run your large language models in a public cloud setting with all the benefits that you saw on the slide before, from a traditional data center approach to a public cloud approach. A little bit more detail on how it looks like and the inner works. So HPE GreenLake for large language models is built on an AI-native supercomputing infrastructure platform where we basically leveraged all the learnings and the capabilities from these supercomputers that we are building. It includes high-performance compute nodes. It includes low-latency interconnects, parallel file systems. On top of that, by default, we have the stack, the software stack that you need to get started. That includes our Cray programming environment. That includes the machine learning development environment and the machine learning data management software. And then on top of that, we even have a default large language model available from our partner Aleph Alpha called Luminous. But of course, you can have any other language model of choice be included in that as well. It also includes an embedded AI assistant and the necessary front end. So what you can do now instantly is bring your data. And my colleague from U.com had a very nice session right before my session, how to do the fine-tuning and the prompt engineering. But what you can do now instantly is bring your customer data and fine-tune a model of your choice in this default GreenLake for large language model environment, and basically instantly get started with all the benefits that you get from traditional data centers, plus all the benefits that you also have from public cloud settings as well. 30 seconds. I think that was my last slide. So thank you very much on the time. If you want to have more information on that, please, on your way to lunch or after lunch, stop by at our booth 507. My colleagues, myself are there to answer any questions that you would like to have. I wish you a great rest of the conference. Enjoy your lunch, and thanks for coming.